In this video, I'm going to go over problems that are similar to what's in your Unit 2 test, Part 2. So this grading rubric will tell you how you're going to be graded on each of these questions. So let's look at this first problem. Does this table represent a function, and explain why or why not? So remember, when we're looking at a relation and trying to determine whether it's a function, we're going to look for a repeated value of x. So in this table, you can see that this value of x equals 2 is repeated. So that is why this is not a function, because x equals 2 is repeated. So in this next problem, it says, does this graph represent a function, and then explain why or why not in a complete sentence. Remember, when we're studying graphs, we want to use the vertical line test to determine whether a graph is a function. So if I draw this vertical line, notice that it'll pass through my graph more than once. So that is why it is not a function, because it fails the vertical line test. So now in this problem, it says, given that f of x equals -2 times x minus 5 plus 3, find f of -2. So what does f of -2 mean? So remember that f of -2 is saying, what is the value of the function when x equals -2? So that's what this is asking me to do. So it's saying, find f of x when x equals -2. So now let's find the value of f of -2. Remember, to do this, I'm going to go to my equation and then plug in a -2 everywhere I see x. So this is going to become f of -2 equals -2 times -2 minus 5 plus 3. So now remember, to simplify this, I'm going to use order of operations. So I'm going to start off with simplifying what's in the parentheses. So I have -2 minus 5. So this is -2 times -2 minus 5 is -7 plus 3. So now I need to do the multiplication. I have -2 times -7, which is 14. Then I have 14 plus 3. Now finally I need to add these two numbers together. So I have 14 plus 3, which is 17. So I have f of -2 equals 17. So in this question, it says that the graph of part of a linear function is shown on the grid. Write inequalities to represent the domain and range of the parts shown. So remember that domain and range, we can use this mnemonic to remember what they stand for. Remember that domain is the x values, range is the y values. So domain is x, range is y. So remember, when we're looking at a graph, we draw in our boundary lines to figure out the values of the domain and range. So if I draw in my boundary, remember, domain is going to go left to right. So the leftmost boundary of my graph is here, and my rightmost boundary is here. So the leftmost value in my domain is at -5. Since there's an open circle at -5, I'm going to use a less than sign, and then I'm going to write x because I'm talking about the domain. The rightmost value in my domain is 0, because remember, everywhere along the y-axis, x equals 0. So I have 0, and then since I have a closed circle there, I'm going to use a less than or equal to sign. Now let's talk about the range. The range is going to go from lowest to highest. So this here is going to show me the lowest point of my graph, and this line will show me the highest point of my graph. The lowest value is -1. Since it's an open circle at -1, I'm going to use a less than sign. Since I'm talking about range, I'm going to write y. And then the highest value in the range is 4. Since there's a closed circle at 4, I'm going to use a less than or equal to sign. So in this question, it says the graph of part of a linear function is shown on the grid. Write inequalities to represent the domain and range of the parts shown. So I know normally I write my inequalities like leftmost, and then I have my x, and then I have my rightmost. Well, this problem is a little bit different. If I'm looking at the leftmost boundary of x, there's no leftmost boundary because this arrow tells me it goes on forever. So I'm going to leave off that left part. I'm going to write my x, and then I'm going to think about the rightmost boundary. Well, on the right side, there is a boundary because it's right here, which is x equals -5. Since I have a filled in circle there, I'm going to use the less than or equal to sign. So it's a similar situation with a range. If I'm talking about the lowest boundary, there is no lowest boundary, right? Because this arrow tells me this line keeps going down forever. So I'm just going to skip the lowest boundary and I'm going to write y. And then I'm going to talk about my upper boundary, which is right here at y equals 6. Since I have a filled in circle at 6, I'm going to use a less than or equal to sign. So in this problem, Erica is selling candy bars to raise money for her school field trip. She's been given 10 candy bars to sell and must sell at least 5. The amount of money she makes from selling C candy bars can be modeled by the function f of c equals 5.25c, where c is the number of candy bars she sells. Describe the domain and range of this function. So let's look at the important information we have here. She's been given 10 candy bars and must sell at least 5. The amount of money she makes from selling C candy bars can be modeled by this function, and we're looking for the domain and range. So let's look at this. Remember, first we need to discuss whether this is a discrete or a continuous function. Now let's look at the function we've been given. We have f of c equals 5.25c. So let's think about inputs and outputs. So c is the input, which is the number of candy bars. F is the output, which is the amount of money she makes. So remember, when we're talking about Dixie Royd, remember that tells us the domain is the inputs, range is the outputs. So the domain is going to be determined by C, range is going to be determined by F. So when we talk about if it's discrete or continuous, when we talk about candy bars, you can't have half a candy bar or a fourth of a candy bar. We can only sell whole numbers of candy bars. So that's why this function is going to be discrete, because although money is continuous, candy bars can only be described by specific values. So this is going to be a discrete function, so that means we're going to have to use lists for the domain and range. So let's talk about the possible domain values. Well, she's been given 10 candy bars and must sell at least 5. So that means that she can sell 5, 6, 7, 8, 9, or 10 candy bars. Now we need to figure out the range values based on these values in the domain. So the candy bars are C. So we have these values 5, 6, 7, 8, 9, and 10. So now we need to plug into f of c to figure out each value of the range. So when we plug in 5, we get 5.25 times 5, which is $26.25. So that's the first value in the range, $26.25. Now we need to plug in 6, so we get 5.25 times 6, which gives you a value of $31.50. So now we need to plug in 7. We have 5.25 times 7, which gives you a value of 36.75. Now we have 8, so we have 5.25 times 8, which is $42 even, so we have 42. And then we have 5.25 times 9, which is $47.25. And now finally we have 5.25 times 10, which will give us $52.50, which is the final value in our range. So for each value of the domain, we have a corresponding value in the range. So let's look at this problem. Roger rides his bike at the park every day after school. It takes him 3 minutes to ride to the park and 2.5 minutes to bike a mile. The amount of time it takes him to bike m miles can be modeled by the function f of m equals 3 plus 2.5 m. He bikes at least 1 mile a day, but no more than 10. Describe the domain and range of this function. So it takes him 3 minutes to get to the park, and then 2.5 minutes to bike a mile. So m represents the number of miles, and then f of m equals 3 plus 2.5m. He goes at least a mile, but no more than 10. Let's talk about the domain and range. So remember, first we need to determine whether this is discrete or continuous. So let's think about this function, f of m equals 3 plus 2.5m. So m, which is the input, is the number of miles. F, which is the output, is how much time, right? So time in minutes, so it's just how much time he's biking total. So if we think about this, miles, we can bike half a mile, we can bike a quarter of a mile. There's not a specific number of miles, okay? So miles is continuous. If we talk about time in minutes, you can bike half a minute, you can bike a fourth of a minute. So time is also continuous. Since both of these variables are continuous, we're going to use a continuous function, so it's going to be described by inequalities. So now we need to think about the lowest and the highest value. So the domain, since the input is m, the domain will be m. The range is the output, so that'll be f. So let's think about this. He's going to go at least a mile, but no more than 10. So that means that the possible values in the domain are 1, less than or equal to m, less than or equal to 10. So now we need to figure out the range values that correspond to these. So the highest value will be at 10, and the lowest value will be at 1. So if we talk about f of 1, we're going to plug into our equation. So we have 3 plus 2.5 times 1. So that is 3 plus 2.5, which equals 5.5. So 5.5 will be the lowest value in the range. And then the highest value will be when we plug in 10, we get f of 10 equals 3 plus 2.5 times 10. So that equals 3 plus 25, which equals 28. So f is going to be less than or equal to 28. So that's how you describe the domain and range of this situation.